This will be the optional manufacturing review for our chain breaker. Mentioned in the lectures that we might die cast this, we might cast it, probably not forge, but there's several different machining processes that we would do after. So if I was just looking to pick up material and we were at, well, let's go see, we'll fly that out. And the 0.79 across the flats works out to about 11/16. So right there, that's probably not going to be too common of a size, but we'll see what we get. So 11/16. Not terrible on the price. Low carbon steel, easy to machine. 3 foot, 6 foot. So if we look at the product detail, go ahead and zoom that out a little bit. There we go. So they're saying plus nothing, minus 0.02 on the across the flats. So that's not bad. And price-wise for a prototype concept piece, I said $9. At the 1.5 inches on a foot, we would get 6 out of that. So material-wise, that's not terrible. So okay, we verified the material's attainable. If we were to go that route, let's go back into the original sketch and we'll start making adjustments. So I want to leave that dimension. So I'm going to switch it from driving to driven. And since we had a tolerance, I can pretty much see if I can get that without the midpoint. Here we go. So 0.688 plus nothing minus 2. It's pretty close. So 4 thousandths. All right, so we're a little bit closer to the 800 that we would need for the centering, but I'm still not too worried about those. And this was all pretty good. We had the widths 90 thousandths, 190 thousandths. Those aren't super critical, so we would need to have the actual chain product that we're going to put in there, and then we could go back and adjust. So again, with the dimensions, would look at making that, switching it from driving to driven. And if we go to midpoint, so I need to figure out which midpoint that was. So we'll drag it off a little bit and go back and make it midpoint. So 0.397, that number looks a little bit closer to what we would want to end up with, just slightly below center line, so that's okay. Still don't have any real preference on that particular piece. Let's go ahead and, well, since we're making those driven, we'll stay with that as a strategy. Select Control, select the center of the circle and the origin and make those vertical. And we're kind of going down through the checklist as I do those as well, that I'm not missing anything, that all those numbers are lining up. And what happens is if I don't make that driven, I apply the relationship of vertical, it's going to go over defined. And then I would just right click and make it driven. The other location for this is on the dimension, other, check the driven. Okay, so now we've centered all of those up. The issue that I brought up with this small geometry, particularly this face and this face, is unless this is cast, I really don't have a way to machine this. If we were to make this part separate and clamp it on, added expense, no expense, hardware, just to be able to drill those holes. So my what if scenario says, let's go ahead and make a configuration. And this will be, in this case, I want to do an original. And I'm going to modify the default so that it updates through the assembly and into the drawing. And we haven't really related anything to this geometry, so it shouldn't be too crazy. And if we go back over here, I'm just going to square this out. And the other item that I would consider utilizing here would be a radius tool that we could get into the corner a little bit. So let's go ahead and make that tangent so it lands in the same spot. Okay, and then that one didn't go vertical, so I give it that little drag. So let's go ahead and put a fillet in here. And with the 90 thousandths here, in between those, I would really want to stay, let's see, I could probably go 3/16, which I think 30 thousandths is probably going to be about the max that I'm going to get on a nose radius there for a hog mill or for that geometry without custom grinding it. And then we'll do pretty much the same thing, an extrude cut and up to surface. Okay, so now I have something that if I'm going to machine, I don't really see those as stress risers, but if we did manage to put a load on the chain, that would be a potential stress riser. Well, pretty much all of these would. So I would want to consider maybe using that same tool or combination of tools, at least on the wide ones. I don't know about the being able to go through that geometry, but and also if we were doing a die cast on this, that would help with the blend on the casting, not having those sharp corners, flashings, all of that other geometry to contend with. All right, so just a few changes, but if I'm machining this, I could potentially have a ball end mill go in from this direction as long as I didn't run into anything here. Small 3/16, and might end up with just a little bit of a scallop there, would have to see. And that would be the other thing, is if I shifted this over, if there was enough clearance, we would shift this over a little bit, maybe make this 1/8 of an inch, give us a little more room to work with. All right, so I'm going to save that, and then we'll switch over here. We said that the length was about 1 inch. So I'm going to stay modifying the defaults, and this is a choice that we have to work through. So if I were to change the 1 inch, so the overall, that piece, we had a 1/2 inch on the flat. So if I was to change that to like 5/30, well, that would just barely get through. And then the update. Okay, so all right, I'm going to have to go back and measure because I don't remember the numbers right off. Okay, so the assembly, and we'll collapse the exploded view. Okay, so that's in parallel. That would pretty much push it out of the end as well. So let's, this is getting, so if we suppress those two, it's getting to the point where I'd want to see about managing that geometry. All right, so we had the overall length, distance. So since this was kind of set up in a chain fashion anyway, let's go ahead and see what we can do with that tab. I think that ended up being 0.32 when we did the math, so we'll go ahead and update that. Okay, well, on the assembly then. Okay, so put the chain in, it contacts there, pushes through, locates it, and we still have about a 1/4 inch that we could shorten that up, so we'll go back to handle, look at that, and I'll just subtract 0.25, let it do the math, and when we rebuild it and save it, then go back into the assembly. Alright, so at its end I have a little bit of clearance if the threads don't go all the way. We didn't put a thread relief, but if the threads don't go all the way to that point and try to bind up, at least there's a little bit there to work with. And then if that goes to full contact, then it'll push through. So we'd still like to know the width of the chain, mainly because this is still looking like whichever grooves those set in, or if the roller is sitting in between those, then we're not quite where we would want to be. All right, so I'm going to go ahead and unsuppress and unsuppress. Are we still in? Yeah, we're in the default. And then on the dynamic, we would be able to go through and make those adjustments. All right, so make sure this gets saved. And then back into the hex, also mention that this piece, well, in this case, if we did another, well, we had the original and then this is the modified. So in this case, we'll just right click, sketch, S key, need that selected, that edge selected, and then we can convert. And then we'll be to features, extrude cut. And we'll see how much interference we get. So up to next, yeah, kind of going through into that geometry. But even that wouldn't necessarily be a deal killer if we stopped it a little bit short and let the drill point come through, then the handle would have something to seat on and it would have that full 1/4 inch to work with. So maybe we'll do that instead. And if I stop it, oh yeah, this isn't the whole wizard, so it's not going to consider the drill point at this with this one, and that's one of the probably the downsides to the configuration is I would just need to create another 5/16 diameter, maybe suppress that one out, create another 5/16 diameter to work with. So, all right, so let's go blind. If I go 0.25, then I'm pretty much assured that it's not going to include the fillet, which is always an interesting, not sure how I can make that geometry. If we went another 30 thousandths, or we could reorder the fillet, but then the fillet wouldn't necessarily come all the way across. So that one we can do 0.28. Cuts into the material a little bit, blends out pretty close. Still showing that that step, which would be kind of an angle, but we could refine that geometry if we decide that's the way we want to go. Now, I expect when I come back over to the assembly that when it rebuilds that we'll have a rebuild error. And we start making these changes, that's going to come with the territory that I need to find that geometry. We did a coincident there. So if I were to suppress that one out, make those coincident, it pushes in a little bit more, but we've got that better engagement. And in this case, if I were to take a 5/16 end mill and go through, the end mill would be a little bit undersized, possibly a press. Still would like to machine this all from the top and then rotate it over and pick up this geometry and just drill and tap from that end. So it may be something we look at. Let's see, what did we have there? So 1/4 inch in revision instead of the 5/16. I don't know that there is that much load that a 1/4 inch piece of stainless here wouldn't do just as good as the 5/16, and it would also let us go through, reach this geometry, drill and ream if we needed to perform the press, put a little green Loctite on it to glue it in place, and now we have something that I can back out of relatively quick by looking at those other configurations and swapping those around. But that gives me something then that we'll go through the next phase and look at the sheet geometry. And so a little bit of an issue there because now the assembly is still the same sheet. Now the geometry changed. So this would be where I would really want to consider. And since I'm have that available, I could leave this as the original and I could duplicate that sheet, or I could save this whole thing as a new folder. And if we copy that sheet and paste it, and it should paste after the selected sheet. Do you want to rename them? In most cases, yes. In this one, no. All right, so sheet 2 of 2, and when we go this route and go back to the default, then we'll generate that error, and we'll have that. Yeah, not sure why it lost. Oh, because I went to the center mark, not to the geometry. Get our smart dimension. Put in the 0.5. See if we can find some room to put that that bottom in there. So let's see, the 11/16 going to 11/64, or 11/32 would be the 344. So we're close there. And I'm just going to quickly, would really need to consider changing this a bit more to clean it up. But for a quick design review or alternative presentation, this would get us pretty close pretty quick. And then you can see in the cut the blends of the radius, where it comes through, those types of things. So all of that updated. Pretty much could do the same thing, copy, paste after selected. If I go back into this, pick the configuration, this one, let's see, you need to go the other way. I think I did the original first. And we'll make sure to rebuild sheet 1. All right, so what was having issues here? So let's double check. It's in the default with the exploded. And it has all of the changed geometry. So let's go back into the assembly. Make sure that rebuilds. Geometry no longer present, so that's why we're having the issue. So on the chain handle, oh, it's still hanging on to that coincident, even though I suppressed it, or thought I suppressed it. All right, so now both of those are suppressed. All right, so didn't push all the buttons in the right order apparently, so let's make sure that saves, updates. And this is going to be the iterative process where we're just going to check, double check, recheck, and then check again. And I can put this up as production. What's going to be an issue is to manage these documents. So as soon as we have a decision, or as soon as I've made the decision, then we would go through and delete or update the ones that we didn't necessarily need. All right, so just using this as an example, we can leave the 2 place decimals, and we mentioned that I would want to possibly tighten up that tolerance. So if this was going to be a drill and ream process, I would want to look at making this like the 0.1875. And if we were going to I'll stay with the stainless. This one's low carbon. Might do. So if we go to rods, steel, low carbon steel. That one only goes to 1/4 inch for that particular material. So let's go through the filter and find a piece of 3/16. So low carbon tolerance is pretty wide. Don't really want to spend twice for a precision. So we would just try to make sure that our tolerance and the materials are matching. So -2 to 0, a little bit more, but easy to machine. 1045, yeah. All right, so the main thing is looking at the manufacturer's tolerance. If this was a -3, that would be 184.5. That would still be loose, and on the high end, that could be as much as 191, which would be a really hard press. So in that case, we'd also need to consider that I might have to knurl in that inner geometry if needed. So let's make this a, don't know that changed, but let's override the tolerance, and we'll put it out to 4 decimal places. Based on what we just saw, we would want this to have a bilateral. So once we start going in down the tolerance road, I don't want it to get any bigger, but it can get 5 thousandths smaller. And then based on that, I don't really need the 4 decimal places, so at least 3 decimal places to control it. So we would go through and do that to the geometries, so that as a reminder and for manufacturing, even a double check that we would be able to manage and verify our production process for this piece. Okay, and then on this piece we have to go to 3 decimal places. This one can be a symmetric. And the manufacturing process on this is to cut off the rod at 2 inches plus or minus 10 thousandths based on, we haven't modified that yet, but typical 2-place is going to be plus or minus 10 thousandths. And when we go back into screw, we'll look for that Boss extrude. And I'm not going to carry it out. The material isn't that precise, but I do want it to be a little bit closer. So I would see the interference or the clearance based on that geometry and the shape. So said is if this ended up on the high side, it would be a really hard press. On the low side, it would be almost a slip fit. We will need to take those into consideration to be able to manage our geometry. So once we had a consistent material supply, then we could decide, do I need to put a straight knurl in here so that when I press it into the other piece, there's material to give. There's really all kinds of accommodations that we can make to this geometry. Pretty much the same thing with the 0.31. We would have to first of all decide if we're going to switch over to the 0.25. Is the rod available? What is the tolerance on it? What do we call that out as? And then come back over to the sheet 2s and look at that tolerance and variation that we can manage there. So certainly a lot further we can take this, but that will be a good overview of the manufacturing review. And as I flip through this, I noticed that the geometry didn't change even though I had made the adjustments to the views. So if we go back and open that up, change was, now let's get back to where I can find my geometry, as to the sketch. And what I needed to do, I was watching the numbers, so I need to change it. For the default, this is going to stay the same. This is our proposed modification. So when I go over to the original and type in the 1.13, I need to make sure that I'm telling it for this configuration. And rebuild and save. And that makes the adjustment. And most of the time I'll go through and activate that other configuration just to make sure. And then sheet 3 should be the one that updates, and sheet 2 stays. So let's go ahead and save that, and we'll try and catch those little issues as they arise as we go through the process.